Hi, Assalamualaikum. My name is Nurul Syafika binti Mohammed Azmi. So today I'm gonna present for group presentation for chapter 4, which is optical measurement. Okay, so first is optical fiber identifier, OFI. This is the picture of optical fiber identifier, OFI. Here is the part of optical fiber identifier. First is fiber growth, LED, on-off button, and VFL. Okay, now first is the define. Designed to identify CW signals in fiber optic cables without interrupting service or damaging the fiber. Second is the method. Clamp onto a fiber where they induce a safe macro band in the fiber which allows a small amount of light to escape. Third is the function. To collecting and analyzing the light, the presence of network traffic, test tune and CW signal is detected and the direction of signal flow is determined. Okay, four is the types. There are three types: single mode, multi-mode and plastic optical fiber, POF. For the second one is optical spectrum analyzer. It's the picture of optical spectrum analyzer. Part of optical spectrum analyzer, there is soft keys, primary function, control function and numeric keypad. Analyzer is an instrument for measuring optical spectra. The application for optical spectrum analyzer: first, testing device laser and LED light source for spectral purity and power distribution. Second, testing of optical system. And third, measurement of the wavelength dependent transmissivity or reflection of optical fiber device. For the function of optical spectrum analyzer: first, measure optical power as a function of wavelength. Second, can divide a light wave signal into its constituent wavelength. And the third is the profile is graphically display signal power versus wavelength. Go to the specialist spectrum analyzer. First, some high-resolution spectral analyzers are meant for specific application in spectroscopy. Second, there are devices for use in optical communications which are restricted to one or more telecom wavelength band. Third one is optical time domain reflector, or TDR. It's the picture of optical time domain reflector, or TDR. Reflector or TDR. An optoelectronic instrument used to characterize an optical fiber, injects a series of optical pulses into the FUT and extract light that is scattered or reflected back from points along the fiber. And last, the strength of return pulse is measured and integrated as a function of time and is plotted as a function of fiber.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alya Fatini binti Rozak. So I will continue the presentation about the basic optical fiber equipment. So I will explain about the OTDR's function. There are four functions for OTDR. First, measures the elapsed time and intensity of light reflected along an optical fiber. Second, used for estimating the fiber's length and overall attenuation. Third, for locating problem in an optical network. And two, locate fault. 4, to measure cable attenuation and optical return loss. Next is reliability and quality of OTDR equipment. This is the image of OTDR. This is the monitor for the signal or wave, and this is the signal button, function button. Okay, there is a three explanation about reliability and quality of OTDR equipment. First, accuracy. Accuracy is the correctness of the measurement. Second, the measurement range, the maximum attenuation that can be placed between the instrument and the event being measured. Third, instrument resolution, a measure of how close to events can be spaced and still be recognized as two separate events. Okay, next is types of OTDR light test equipment. There are three types: The first one is full feature OTDR. The feature rich and usually larger, heavier and less portable than either the handheld OTDR or the fiber brick locator. Number 2, handheld OTDR and fiber brick locator. Designed to troubleshoot fiber networks in a field environment. Number 3, RTU in RFTS. RFTS enables fiber to be automatically tested from a central location. This is the specification of OTDR. So I just attached the image of the specification that I got from the Google. So this is the specification. Okay, next is for the fourth equipment is first fusion splicer. Fusion splicer. Okay, so fusion splicer is equipment, while the method we call as fusion splicing. Fusion splicing is the act of joining two optical fibers end to end. The source of heat used to melt and fuse together the two glass fibers being spliced is usually an electric, but can also be a laser, a gas flame, or a tungsten filament through which current is passed. Okay, the function of fusion splicer is used to permanently join two fibers by heating and fusion process. Okay. It is most widely used method of splicing, and it is lowest insertion loss and virtually no back reflection. So this is the image of fusion splicer. Okay, next is specification of fusion splicer. So I just attached the image or the details, the specification of the equipment that I got from Google too. Okay, the last is I will explain about the steps in fusion splicing. Okay, the step 1 is put on the fusion splice protection sleeve. Step 2, strip the fiber. Strip back all fiber coatings down to the 125 micrometer bare fiber. Clean the bare fiber with 99% isopropyl alcohol. Step 3. Cleave the fiber. The fiber needs to be cleaved with a high precision cleaver. Most splicing machines come with a recommended cleaver. Fiber cleaving is a very important step as the quality of the splice will depend on the quality of the cleave. The step 4 is put the fibers into the fiber holders in the fusion splicer. Press the start button to start the fusion splicing. Okay, this is the last step for the fusion splicing. Step 5, heat shrink the protection sleeve to protect the splicing joint. Okay. That's all from us. Thank you.